Hi class, this is Michael Yu doing the Reimann song project. So today we went to the Woodbury, the outlet center, and we did some shopping, and it took us an hour to get there. So I figured why not? So I recorded the time and the speed at that moment. So let's take a look. Because we were on a bus and it was really bumpy, so I used my phone to record the velocity at the time, the speed at the time. So at the 5 minute, it was 60 miles per hour, and I created a little chart to record this. So at 5 minute is 60 miles per hour, and 65 at 10. 70, 68, 69. So this is everything. 5 minute was 60 miles per hour and 10 miles per hour. So these are all my datas, and now I'm gonna create a graph, a velocity time graph, and use the Reimann sum, and I'll use the right hand sum to calculate the distance traveled. So from the data I collected, I created a velocity time graph, and now I'm gonna plug in the points. So my data is right here, and let's do this together. So at 5 minute, the velocity. The speed is 60 miles per hour, that's right there. And at 10:65, which is about like that. 70, 68, 69, 60. 35 is 71, 40 is 55, and from that we had some traffic and we were almost there, so we slowed down to 5 miles per hour and 1 miles per hour. 3 miles per hour and 2 miles per hour. So it's a lot difference between these dots and these 4 points. So now I have connected the dots, and here is the velocity time graph, and my task now is to use the right-handed Reimann sum, which is like that for the first 5 minutes, and calculate the area underneath. So I'm gonna do that every 5 minutes for the entire hour, and calculate this distance traveled and compare to the real distance, which is 38.5 miles to the data I have. So what you realize now is that I collect the data every 5 minutes, and these speed I have are miles per hour. So to do that, I have to convert minute into hours to get the right time for the velocity. So 5 minute over 60 minute, which is an hour. Is 1/12. So I have to do the calculation, which is 60 1/12 plus 65. So I'm gonna do that for the entire data, and yes. So after a lot of mental calculation, no, I'm kidding. So I did all that on the calculator, and I got 44.8 as the final answer. So 44.8, and to show that on the graph, it will be like this. So use the right hand sum, that will be like and what we just calculated is the area underneath those rectangles. And you can see that 44.8 is clearly bigger than 38.5. 44.8 is clearly bigger. And what that possibly is that this area and the things that's above are it's not that accurate. I mean, it's a Riemann sum, and to make that better, we can either divide. We can just divide the time that I collected into smaller digits. Like for example, if I collect data every 1 minute, it's definitely going to be some swings out these datas.